Good morning. Today we'll start industrial automation. So this is one of the elective in 6th semester. You have total 3 electives. One is mechatronics, second is industrial automation, and third is robotics. Out of these 3, so I am going to deliver lectures on industrial automation. So the code of this subject is DLOC 6023. It has 4 credits. So what is objective? So objective of this subject is to study the need for automation, its advantages and limitations, to study the basic functional elements of automation, to familiarize with the level of automation and strategies of automation, to acquaint with control of mechanical operations involving pneumatic, electric, hydraulic and electronic systems. After completion of this course, the students will able to demonstrate the basic industrial automation. That is, these are some outcomes. So outcomes are students should able to demonstrate basics of industrial automation. Students will be able to identify various types of automation. Students should be able to demonstrate use of automated controls using pneumatics and hydraulic systems. Students should be able to illustrate or demonstrate applicability of PLC in process industries. Students should be able to design electro-pneumatic circuits. So these are some outcomes after this course. So this syllabus consists of total 6 modules. So first is Introduction to Automation. So this chapter consists of some definitions, fundamentals of automation, then reason for automating, then basic elements of automated systems, that is power, program and control systems. And so this first module consists of advanced automation functions like safety, maintenance and repair, diagnosis, error detection, recoveries. Also we are going to discuss levels of automations, then automation principles and strategies, that is USA principle, 10 strategies of automation and production systems, then automation migration systems. So let us see one small video which illustrates the function of automation. Let us see.
Manufacturing, factory owners have looked for ways to increase productivity and lower cost. This resulted in many of said factory owners looking to automation to help their bottom line. So what is automation? According to the Merriam-Webster dictionary, automation is the automatically controlled operation of an apparatus, process, or system by mechanical or electronic devices that take the place of human labor. What does that really mean? If you walk inside a modern manufacturing plant, you might see something like this. Robots and other automated machinery that can run typically without the need for human involvement. Automation results in better efficiency. Let's face it, humans make mistakes, and they're not always very consistent. Automation practically eliminates error, increases productivity, and allows for better monitoring and control of the manufacturing process. Automation also allows for a certain task to be replicated over and over again. But automation manufacturing isn't just more efficient, it's also smarter. Data is generated throughout the process and is used by various elements along the line to better control workflow. Connecting the line through a supervisory control and data acquisition, or SCADA, system allows the entire team to gain insight to what is going on during the manufacturing process and notifies employees of any potential problems that are happening on the line. Robotic automation started showing up in factories in the 1970s, and as time has passed, the technology has become even more sophisticated. As it advances even further, it is not outside the realm of possibility that one day manufacturing facilities could run without the need for humans on site at all.
So this is about some introduction to automation. In next model, we will compare mechanization and automation. Mechanization means what? Using of machines which elements human interference, which reduces energy. So in second model, we will discuss difference between mechanization and automation, then product cycles, then different types of automation, that is hard versus flexible automation, then capital intense automation versus low cost automation. Then we will discuss types of systems, that is mechanical systems, electrical systems, hydraulic systems, pneumatic systems, and hybrid systems. Then we will discuss automation with the help of some mechanisms, that is cams, Geneva mechanisms, gears, etc. We will discuss some different examples. Then automation in case of line, assembly line, that is automated assembly systems, transfer systems, vibratory bowl feeders, non-vibratory feeders, part orientation, that is feed track, part placing, part escapement systems. So these things we will discuss. Also we will discuss some material storage handlings, transport systems, also AS, RS, that is automated guided vehicles, AGVs, and conveyor systems we will discuss. So in second model we will cover all these things. In third model we will discuss about pneumatics and hydraulics. In our college we have separate mechatronics lab in which we have the pneumatic kit as well as hydraulic kits. So hydraulic and pneumatic devices, we will discuss the different types of valves, actuators, then auxiliary elements in pneumatic hydraulic systems, their applications and use of their ISO symbol we will discuss. Also we will synthesize and design of circuits up to 3 cylinder. We will design some circuits for different applications, the pneumatic circuits, electro-pneumatic circuits and hydraulic circuits for multifunctions or sequence functions. With some examples we will discuss in this model. Then design of electro-pneumatic circuits using single solenoid or double solenoid valve with or without grouping we will discuss. So this is about third model. In fourth model we will discuss different sensors and actuators. Okay. So we know sensor is nothing but transducer used in mechatronic systems, in automation. So with different characteristics and functions of this sensor, the selection of sensor is very important. So displacement, for temperature, for acceleration, for force and pressure, base, the static and dynamic characteristics. Accordingly, we are going to select different types of sensors. So sensors are there, the system is there, interfacing is very important. So concept of interface, bit accuracy, the sampling speed, amplifying electronics and microcontroller. So this part we will discuss in this model. So this is about sensors and interfacing of sensors with the system. Now we will discuss actuators. Actuators, so what is actuator? The principle and selection of mechano-electrical actuators, DC motors, stepper motors, solenoid actuators, servo motors, BLDC. We will discuss different types of motors, different types of actuators. In fifth model, that is industrial control systems. In this fifth model, we will discuss process industries versus discrete manufacturing industries, then continuous manufacturing systems versus discrete control systems. Then we will discuss computer process controls, forms of computer process controls we will discuss. Also we will discuss discrete control using PLCs. So here programmable logical controller we will discuss, and its architecture, ladder logics we will discuss. So in fifth model we will discuss detail about programming for different types of logic gates, latching, timers, counters. We will see some practical examples of ladder programming. So nowadays in many industries some systems are coupled with PLC logic controllers, where you can program these PLCs and you can carry out the operation automatically. You can control the operations. So you must have knowledge about PLCs. So in case of in industrial electronics, you studied microprocessor or microcontroller. So here in this subject we are going to study programmable logical controller. Okay, in mobile you have microprocessor, okay, microprocessor chip you have. In computer also you have microprocessor. But all these computers you cannot use in industry purpose, in some different conditions, in variable conditions, means temperature variation, pressure variation, noise and dust area. You cannot use computers there. This microprocessor you cannot use, but in such case, for robust work and for variation in control conditions, variable conditions, the programmable logical controllers are used. Okay, it has similar function. It controls, manage all the activities, mechanical activities. So we'll discuss in this fifth model, and then we'll discuss the last model, that is robots. So what is robot? So it is a machine. It is a humanoid machine. It is fully replacing human being. But it is a machine. It is a programmable machine. So we'll discuss introduction of robots, types and classification of robot, then selection of robots, then robot degrees of freedom we'll discuss, robot configuration we'll discuss, some characteristics, that accuracy and repeatability. Then we will discuss selection of robots, robot feedback controls. Then we will see different types, that is point-to-point control systems, continuous path control systems. For different robot joints we will discuss. Then related to that robots, the adaptive controls, the drives, transmission systems, end effectors. So we will discuss for robotics. So these robots are used in many applications. So many applications we will discuss. Then in industrial automation this robot is used. We will discuss many case studies. Let us see one video related to robotics. We are watching video of robotics. So robot application in different processes. So magnetic gripper. So these are some examples where we can use robot. So nowadays so many applications like welding, material handling, hot material handling, chemical material handlings. So these applications are replaced with robots. Also in first video we discussed that if you use this, so it is accurate. So there are no errors, so minimum errors or zero errors you can get with the help of this automation. So this is about the introduction of first chapter. So it consists of total 6 models, and there is no exact practical for this subject, but one more practical subject is there, mechatronics, in which you are going to study some practical elements. But we will have 1 or 2 industry visits so that we can familiar with this automation. In this semester we will have 1 industry visit, industrial tour, if possible physically, otherwise we will have virtual industrial tour. So there is no term work, but there is a sessional test. After completion of first 40% syllabus, you are going to face 1 sessional test 1 for 20 marks. Then after 80% completion of syllabus, sessional test 2 is there for 20 marks. The average 20 marks you will get in a final. And at the end of this semester, you will have 80% 80 marks question paper. So this is about this subject, industrial automation, as an elective, and code for this subject is MEDLO 6023. So in next session we will continue with first model, and if you have any doubt and if you want more information, then you can write your comments in comment box. I have mentioned my contact number and email ID also, so you can contact on my contact number in description box. Okay, thank you very much.